Human reliability associates have extensive experience in the power generation industries, both in nuclear power generation and conventional power generation. In nuclear power generation, we've been active since the 3 Mile Island accident in 1979, where we were asked to develop new tools and techniques to quantify the likelihood of human error probabilities. In the conventional power generation sector, we've worked with organisations such as National Grid and Electricité de France in areas such as developing better operational procedures based upon an analysis of the risks in carrying out the tasks, both commercial and safety risks. And for organisations such as EDF, we've worked in the area of power substation operations, where we've looked at the failures that occur which can give rise to serious accidents such as electrocutions when carrying out routine maintenance tasks in, for example, substations. Okay, I'd like to begin by providing this example for the power generation sector of how we use the Human Factors Risk Manager software methodology to analyse operational tasks and produce effective operating procedures. Now you can see on the screen that we have the overall objective of the task in the centre of the screen, and that overall objective is to perform an on-load brush gear maintenance routine. And the way we do this is to first of all state the overall objective, and then we state various preconditions that are necessary to begin this task. For example, we say that the task is being carried out on load because the units are base loading, the seal cut-in routines are up to date, it's going to be carried out by 2 AP4s with specific authorization for this task, and there are a number of other preconditions. So those preconditions are the assumptions that we are making at the beginning of the analysis, and we're not going to evaluate any risks that those preconditions are not actually fulfilled. So immediately below the top goal, we can see that we've set up these 5 subtasks. So in order to do this task, in order to achieve the objectives of the task, first of all we have to obtain the authority to carry out the task, then we have to prepare the unit for brush gear maintenance. We have to maintain the first and second brush gear rings and then return the unit to normal operation. So you can see that when we're carrying out this analysis, we may first of all refer to the original procedures to give us a rough idea of the structure of the task, and then we sit down with a team of operators to evaluate in more detail exactly how the task will be carried out. So starting at the top here, in order to carry out this overall objective, we carry out these 5 subtasks. Now you can see there's a little cross here. That means that that subtask has been broken down into a series of other subtasks. So the first thing you have to do is to report to the centre desk. You have to establish two-way communication between the work party and the control room, and so on. And you can see underneath the boxes we set out who has the responsibility for doing these various type of activities. So that's essentially the agent person involved. So here we have a colour coding that specifies that, for example, the maintenance person reports to the control desk. The two-way communication has to be established between the work party and the control desk. That's done jointly between the work party and the control room, and so on. So this legend here essentially gives us the opportunity to specify the various people who will be carrying out the task. And then this is confirmed by the colour coding that we see here, and also underneath each box it states who's going to do it. We essentially repeat that analysis for all of the various subtasks. If I click on this little symbol again, which is now minus, it will roll back up the details, and then I can open the next subtask, and we can see that subtask is carried out by a different set of people. Team 2.2, this step is carried out by the unit operator, this is carried out by the unit operator, this is carried out by the electrical engineer. And you can see that we can also break down the task to another level of detail if we want to. So in this case, all of these tests are carried out by the electrical engineer. So the process of breaking down the task successively into different levels of detail means that we can produce very effective procedures that provide an overall structure to the task and make it much easier to understand. Now it may be that as part of this task, what we now need to do is to carry out a risk analysis. But before that, I'd just like to mention that all of this information that we're generating by means of talking to the operators and putting these boxes in to represent how they carry out the task. That information is reproduced here in a table, and this table can be just outputted as a Word document, which allows very simple documentation of what we're doing. If we want to insert some warnings in some of these steps in a procedure, so for example, if this is very safety critical, we might say the warning here would be this is safety critical. So we insert the warning there, and then that's going to be reproduced when we produce a procedure from this documentation. So I'll just move that out of the way for the moment. So in this way we work through the analysis, providing various levels of detail depending upon the criticality of the steps that we're analysing. The next thing to do is to analyse what failures might occur. So confirm ring is at earth potential and it's safe to work upon. I'm going back into the risk assessment tab now because we want to look at what type of failures could occur there. So if we click on here, which is an activity type, this tells us this is an action. Actually, I would say this is more likely to be a checking activity because it has the word confirm. So if we want to analyse what sort of failures would occur there, we can actually create some additional boxes here by clicking on this icon. I'll close that first. And we can see that there are two failure mode boxes there. I'm going to set the logic because either one or the other could occur. And what type of failures could occur there? Well, let's have a look. We could have a, let's have a look at the consequent failure types. So if this is a check, we could omit to carry out the check, or we could check the wrong object. So in this you can see that now that information about the different failures has become inserted into this table here. So that enables us, if a check could be omitted, we then say what would the consequence of that, how can we describe that check omitted? So it could be, look at the detail of the task, fails to confirm ring is at earth potential. Okay, so we can see we've now captured that failure. And what are the consequences of that failure if not recovered? Well, it could be that there is a safety hazard there. I'm not going to specify what it is. Normally, we'd be specific about that, what the type of hazard. We say it's a safety hazard if that check fails. And here we can start to analyse things like what could cause the check to be omitted. Well, what are the existing risk control measures, and so on. I'm just going to add some extra columns to this actually. So here we would say what are the existing risk control measures, and the existing risk control measures might be a checklist. And performance influencing factors, those refer to the conditions which may increase or decrease the error probability. So if we have time pressure here, for example, that would be a performance influencing factor. And then we put in here what sort of risk reduction measures do we want to have here. So for example, we would have decrease workload. That may be easier said than done, of course. And so in this way we can document the various types of failures that occur. So now we've analysed the task, we've identified the failures that can occur, we've identified the factors that influence the failures. Now we can create a procedure based upon that analysis. So if I click on create step-by-step procedure from template, then I click on default, it will now automatically create a procedure. And you can see that procedure is exactly the same structure as the task analysis that we just carried out. So this is the preconditions are here, the process overview, which is the top level of the task analysis, is carried out here, and we can see that the various warnings are now being included in the analysis. So here we've got warning if resistance, abandon the task. So anything that we put in the analysis will be repeated in the procedure that's produced from the analysis. So this is then a very efficient process. Not only have we analysed the operator tasks with a team of operators to confirm what's the best way to do the task in order to make sure that it gets done, we're also making sure that we've analysed what the risks are if errors occur. And we've translated all that information into a procedure, and of course it can also be used as part of the input to the training and competency documentation.